Hello there, this is Jay with Web App Zero, and in today's video we're going to learn how to read some Clojure. So a quick Google search pulls up several hits, and you're welcome to peruse these yourself. I recommend many of these resources that come up on the first page. But this video hopefully aims to be on this first page of hits one day. If it becomes helpful enough for enough people, and that means we're doing a good job here. So you may have found us through pathwayclojure.org. If not, you may want to check that out. Hopefully it's evolving quickly from what you see here into something more mature and fleshed out. This video, you'll notice, only takes up half of your screen. That leaves the other half for you to set up your environment just like mine, and you can learn more about that at my website, webappzero.com, half screen training debut. And this half screen setup will enable you to use keyboard shortcuts to play and pause the video while remaining in your editor. So it really gives you a slick workflow, and I recommend checking that out to see if you think it's a good fit for you. So back to the purpose of this video, we're here to learn how to read Clojure. Clojure is a Lisp, which Lisp is short for list processor. It's one of the older programming languages back from the early 60s and late 50s. And one of my first programming languages, my second language after JavaScript, was learning Python. And Python has this reputation for being easy to read. And it is true that it has a certain natural language effect about it. But one thing is that I noticed is when I got deeper into Python and I wanted to dig into the documentation about how the language was structured, I wanted to find some uniformity, I realized that there was a lot of variety in the rules. And for my brain to sort of understand how the compiler was going to see the code, I was having to, get into the BNR, the notation, getting deep into this, and sort of feeling a little bit confused and like I had to keep learning new things. And Python's a great language. I don't have really anything bad to say about it other than to say that while Clojure sometimes has a reputation of being hard to learn or hard to learn how to read, a lot of other people think that it's actually more simple. And there may be more things to memorize that are new, but really as far as the things that we need to understand in the beginning, it's a very simple system, and that's what I hope to show you today. So one of the things that I've learned about learning itself is that before we try to start memorizing things, which I think people maybe get into with Clojure when they get in, they want to memorize this and memorize that, it's really the most important thing in the beginning is just to understand the big concepts. You will have to look up certain syntax on the website to remember what it is, because there's a lot of little syntax sugar here and there. But once you understand the big concepts and you go back and look it up a few times, the memorization will just sort of happen over time. So I really recommend just sticking to the high-level stuff and not trying to get too bogged down in the weeds. This brings us to Clojure.org, which is the website where you can learn more about Clojure, and I'll just show you what the home page looks like so you know you're in the right place. And this will give you an overview of what Clojure is all about, but I'm going to assume that you are interested enough in Clojure that you found this video, which is about reading Clojure. So we're going to jump ahead and show you some resources. This video won't teach you everything, but it will lead you to some resources that you can teach yourself over time. On the Clojure website, if we go to Guides and then click on Learn Clojure on the left there, this is a great page to start on. Learn Clojure, syntax. This is where it all begins, just learning to read the language, to understand what the different forms are. A form is sort of the basic unit of interpretation. As the Clojure reader reads the character stream, the smallest unit of meaning to the reader is called a form. So, for example, the number 42 in this case is a form. The reader sees the number and then a space afterwards, and it knows that's a separate number from the other data and forms in the character stream, and it interprets that to be a number because it is a number. And so Clojure interprets strings, characters, nil, the null value, true, the Boolean value, regular expressions. A regular expression will begin with this hash symbol and then a quote. The hash symbol is a signal to the reader that, hey, the very next character is going to tell you what this is going to be. And so we'll see a few reader macros over the course of this video. A reader macro is different than a Clojure macro if you've heard of Clojure macros. If you haven't, we'll jump into that soon. Keywords start with a colon. Fully namespaced keywords will include a slash, where on the right-hand side of the slash is the name of the keyword, and on the left-hand side is the namespace. Namespaces, here again you'll see a symbol with a namespace. So in this case, clojure.core is the namespace, and plus is the name. Namespaces are spaces for names. A namespace, the purpose of a namespace is to keep code that you write and code that other people write separate from each other so that they don't clash in terms of naming. So in other words, I could write a plus function, and as long as I put it in a namespace other than clojure.core, I won't have any problems with my code interoperating, even though there's another function named plus in the Clojure universe. And so namespaces are a way, they're part of the system that help us to have this universe of Clojure functions out there. So we have libraries are sets of namespaces. Namespaces are sets of names, and those names are associated with values. So those names map to values. You can think of it as a table. A namespace is a table of names and those names refer to values. We'll see a lot more examples of that as we go along. And most of the time, a namespace spans a single file, although sometimes a namespace can span multiple files. I'm getting way ahead of myself, though. The other thing that we have a literal syntax for these collection types. Clojure is all about manipulating data. And you'll see that as we get into Clojure code, the basic form for a Clojure function is it's a set of parentheses here. With the first thing after the opening parentheses is always going to be a verb, and it's usually going to be a function. It could also be a macro or a special form, but for our purposes, we're going to focus on functions for now. Most of the time, it's going to be a function, but it's always going to be some type of action or a verb. So here we have plus 3, 4. The parentheses form a list, L-I-S-T, and Clojure is a Lisp, Lisp, which again is short for list processor, and so Lisps process lists, and they process lots of lists. These lists are expressions, and they evaluate down to values. And so this expression, plus 3, 4, is going to evaluate down to the value of 7. And this notation here, you can see we're actually calling. This is the call site of this function. So the plus function was defined somewhere else. In terms of somewhere else in the code, there is a definition for the plus function that actually instructs the computer what will it do when it sees the plus function. We're at the call site or the invocation site of the function here, and we're calling the function plus with the arguments 3 and 4. So it's the function and its arguments. In this case, plus is a symbol, and symbols you will see are they don't have a colon. Like keywords have a colon in front of them. They're not numbers. They're not strings. It's sort of a symbol is that text you'll see. We saw some symbols up here with clojure.core/plus. Sometimes you'll just see the plus by itself. Here's the map symbol. So anytime you just see a word sort of by itself, if it's not nil, if it's not true, then it's going to be a symbol. And so this little table right here is actually quite helpful. Maybe the only confusing thing on this table are these numbers. There's some things, the way that Java works, it has different types of numbers. The two most important types for our purposes, if you're new to programming, would be just the number 42, it's a regular number, and this ratio. Clojure can work with fractions or ratios. These other numbers, Clojure can convert between numbers for you quite easily, so it's really not a big deal. It's not that complicated. Clojure has simplicity at its core in terms of the power that it will do for you. Many things that you would have to do on your own in Java, for instance. So now that you have seen what a function call looks like, you'll notice that this list just starts with a parentheses. So anytime you see a parenthesis, the first thing after it is always going to be a function, unless before the opening parentheses you see a tick. So if you see a single quote like this before the opening parentheses, that is a signal that I no longer want to treat this parentheses as a function. I want to treat it as data. And here, this data collection, which is a list, contains the numbers 1, 2, and 3. For this reason, for some other reasons, Clojure includes another data structure called a vector. A vector is an ordered data collection, just like very similar to a list. There are technical differences in the underpinnings of lists and vectors. I will just drop a teaser that lists grow from the front and vectors grow from the back. You don't have to worry about that right now, but if you're more advanced, that may help you get started quickly. Sets, again, start with a reader conditional, or a reader macro, the hash, and then a curly brace. That's a signal that that this is a set. That's the syntax sugar to say this is a set. Sets are sets in the mathematical sense in that they will not contain a duplicate item. So each item in the set will be unique. A map is an associative data structure where each map entry contains a key and a value. Here we have the keyword A that's being used as the key and the value of 1. You can use other values besides keywords as keys. So a key is different than a keyword. We could, for example, reverse these, and the key could be 1, and the value could be the keyword A. We can look up the value of a particular key in a map using the key, and we'll get into some of that in a bit. This will be helpful for you to read the evaluation, to look at how the evaluation is different from Java and what you might be used to if you've programmed in other languages. The most interesting thing is that you're able to inject yourself into this process of the reading process. So as the Clojure reader reads the code written in a particular file or in a character stream, we're able to actually influence that process. And that is through the process of writing macros. And macros are like functions that take source code and return source code until it bottoms out at a function, which then the code is compiled just in time by the Java virtual machine, and then out pops some bytecode. Now, I will just say that we also have Clojure script, which transpiles into JavaScript, and that has a couple of different ways that can work, and it's a little bit different, but Clojure and Clojure script share a common core, a common way of doing things. Clojure is really good at operating on data, and a lot of times that data is a sequence of things, a sequential collection. And so the Clojure reader is responsible for reading in the forms and converting those forms into data structures, and then those data structures are what get compiled. This is a superpower, and it's a superpower that Clojure has inherited from Lisp. And the thing that I really love about this is that even though it's a little bit of a mountain climb to get started with, or at least a hill climb, the power that we have at our fingertips as Clojure programmers is really sort of unbridled compared to other experiences in other languages. And while I really actually do love Python and probably always will, for me, once you get over the hump, that it actually sort of becomes easier with Clojure because of the uniformity of the way that it works. So I encourage you to kind of read through this on your own, the rest of this. What I'm going to do now is sort of give you a nickel tour of the Clojure website, how you can teach yourself, and what resources will be most helpful in that process. So let's carry on. First thing that I want to show you is one of the most helpful resources, and they've just added this to the website recently. You can also help improve the website by giving feedback to the folks in the community. If we click on guides, over on the left-hand side, there is a link called Reading Clojure Characters. If I click on that, you'll notice it's got a cool URL called Weird Characters. It has a table of contents on the right-hand side, which you can visually parse to find something you might come across in the wild. For example, a var quote is a hash symbol with the single tick. So if I click on that, it's going to jump me to the section. The other thing that I can do to get there, if I can't find it quickly visually, is I can just do a browser search on this page, enter hash tick in there, and keep pressing my down arrow until I arrive there. The other way that you can search for that is in Google. You could do hash tick site colon and then the website name. And that will do a search just within that website. And I've found that tip to be helpful. Moving along, the guides we've talked about. Let's back up over here. If I go to guides and I go to learn Clojure, I'll want to do the syntax, the functions, the sequential collections, the hash collections. Just you can go through those in order. And then once you've completed those introductory materials, you may want to start reading a book like Clojure for the Brave and True, which you can read more about at braveclojure.com. And once you start getting out in the wild and writing code and working on code, you will want to start digging into the reference material. So you can find the reference here. The reference material is, I think, written in a nice order, maybe with the exception of transients and transducers. You might save that, save those toward the end, but they may have written this very specifically with this order in mind, so I don't want to steer you in a wrong direction. But I would just say that it's really helpful to come in here and read this reference material. And while there are a lot of great books out there, and I recommend that you read them, having a single source of truth and coming back to this reference material has helped me feel like that there's sort of one place I can go and get the answer that I need in a concise way. The other thing that you have is you have the API, which these are the actual functions. So if you come into Clojure, you can go to Clojure Core. Here are all of the functions in Clojure Core. That's pretty much it. The other thing, check out the community links in here. There's just really great stuff. The next thing I would show you is REPL.it is an online Clojure REPL where you can save your work. You can name your REPLs. So I have a named REPL here called Clojure, and you can then save your work and save your history. I'll just show you that this works well. I can do +2 3 here and execute that. I'll see the output over on this right-hand side. I can clear the output, and I find this to be really helpful. So if you're a little intimidated about installing things on your computer, or you just want to dabble and you want to try things out, I recommend this as a good place to do that. Once you're ready to sort of commit to Clojure and you feel like this is something you want to pursue, it will make sense for you to install a REPL. And again, I'll refer you back to the reference material, the guides, and under Learn Clojure, when you go into the functions section, in the syntax section, it has a section on the REPL and how to explore things at the REPL. So it will give you a bit of an introduction there. You can apply these things to the online REPL and also to a REPL that you might want to install. A lot of people recommend starting off with Leiningen, and Leiningen is a great way for starting off with projects, and I highly recommend learning it, and you'll definitely encounter it, and there's a lot of tutorials out there for Leiningen. But for me, I prefer to use the boot REPL, and for 2 reasons. Let me show you those. So here I'm going to open my terminal application. I'm going to start my boot REPL. Well, first of all, let me show you that I've actually run this before. So I'm going to trash this file. And if you don't have trash installed on your system, it's a nice way to not mess up using your the built-in rm command. All right. So now you'll see that this directory is empty. I can open the REPL with boot REPL. And when I do that, now if I open a new tab over here and well, first of all, let's execute a command at the REPL. I'll do plus 12.3. That gives me 15. I'll do times to 4. That's going to give me 8. And now if I list out the contents of this directory, the nrepl port file there is a transient file. It'll go away. The nrepl history file is now going to contain the previous commands that I've run. And that's really nice. This is one advantage. This is one of the two reasons that I mentioned before of what I like about boot REPL. So I'm not losing work. When I'm working at the REPL, it's being saved into a history file, and that file will stick around. It is then possible to open this history file in the editor of your choice and edit it to your satisfaction, and removing the unwanted function invocations and editing the desired function invocations until they do what you want them to do. This brings us to sort of the final way of doing things with Clojure, which is an editor. And before I show you that, I wanted to remember to tell you about the second big reason of why I like to use boot, and that is because sometimes when we're working at the REPL, we realize that we want to bring in some piece of software that we don't have downloaded from Clojures, Maven, etc. And the way we would do that normally with Line is we would have to go back out and edit our configuration file. We'd have to, and then restart our REPL. Unless with Line you install something called Pomegranate, which is an add-on, a plugin that lets you pull in things without restarting the REPL. Boot has it built in by default. In Boot, you can read the documentation to learn more, but in the Boot environment, we can manipulate the environment. And you can read more about that here. And yes, this may be too deep of a dive for you if you're brand new to Clojure. And that's one reason that people, turn to Line. I will leave that up to you in your own journey. Realize that they're both great build tools, relied on by lots of people, and you can't go wrong, really. Just follow your nose, and you'll end up in the right place. So, one more thing on using the REPL. You can use the doc command from the user namespace, I think both in Line and in Boot. If you're in another namespace, there's something else that you need to do to be able to use the doc command. So if doc is not available in the namespace you're in, you can do a little Google searching. I won't go into that right now, but it's normal. So it's not everywhere by default, but it is in these user namespaces inside of these REPLs. So if I say doc plus, that's going to return the doc string for the plus function. And you'll notice that the name of the function is fully namespaced. The next line after the name is a bit tricky for newcomers. Clojure, a single Clojure function can have multiple definitions, and each definition being associated with a number of parameters that that the function can accept. In this case, there are 4 parameter vectors which show different execution possibilities for this function. So we can call plus with no arguments, this empty vector. We can call it with 1, so x is just some value x. We could call it with x and y, some value x and some value y, so we could call it with 2 things. Or we could call it with x, y, and more. And here more is a symbol, and this ampersand signifies that in addition to having multiple arities, we know that this plus function is has multiple arities because of the multiple vectors. We also know that it is that one of those arities is variadic. I guess at most you could probably have one that is variadic, I would think. And the reason for that is because once you express the ampersand, then you're basically saying it can take any number of arguments. So with the plus function, that looks like this. You have if I call it just plus, it returns 0 as described in the documentation. If I do plus 1, 2, I can do plus 1, 2. I can just do a bunch of numbers. All of these are unique arguments. And so this is probably the hardest thing about reading the documentation to start with, not to mention the fact that Clojure does things in a bit of a unique way. And that has a lot to do with functional programming. Functions are values. Functions can take other functions as input values. They can return functions as values, as output. And there are a lot of patterns that evolve and that programmers use to take advantage of that. This is a good place to shift and start talking about working in the editor. I use an editor called Spacemacs. I also use an editor called Cursive, which is built on IntelliJ. I like both of them for different reasons. And I'm looking at playing around with Atom as well. So Atom may be a good way for you to get started if you have a good experience getting started with it yourself. Par-infer is something you might want to look into after a few weeks of playing with Clojure code, just the vanilla way. That makes it easier to sort of work with all the parentheses. But Spacemacs is built on top of Emacs. It's a kit to help you get started with Emacs. I have found it sort of, really nice to work with. A lot of professionals recommend not starting to learn Emacs and Clojure at the same time, so to keep things simple. And that's perfectly valid. You can go a long way with that online REPL that we looked at earlier. But I do think that Spacemacs is a lot easier than other ways of getting started with Emacs. And if you're a Vim user by any chance, your Vim key bindings, for the most part, will work here in Spacemacs as well. So I thought this would give us a good chance to just go through and look at what some actual Clojure code looks like in a file. And here you'll see at the very first statement, maybe I can make that bigger for you. Okay. The very first statement here is a namespace declaration. This is a special form, and you'll see these at the top of Clojure files. By the way, the name of this Clojure file is reading_clojure.clj. And the namespace will be, it will have the same name as the file, where underscores are turned into dashes, and the file name is dropped. That is how the namespace name is derived from the file name. In Clojure, a value like 3, when the compiler comes across a value like 3, it's just going to return the value 3. So if we executed this, say, at the REPL, if we put in 3, we're just going to get back 3. Everything in Clojure operates around values. Even composite things like maps and composite data structures, nested data structures, vectors within maps, all of these things, we think about them as values. And these values are immutable. They don't change. We input those existing values into a function, and out will come a new value. And that sounds grossly inefficient, but it operates a little bit like Git, where only the things that have changed are actually created anew in memory. We won't go too deeply into that because our main purpose here is reading Clojure, and you will be able to find out a lot more about that as you dig into your own reading. So let's go through here, and I just want to show you, you can ignore these symbols all the way on the left-hand side of my screen, these little green lines all the way on the left here. Those are just my editor telling me that this has already been evaluated. So I have a REPL attached to this file. So I can evaluate forms here at the REPL, and you can see that down at the bottom that returns 5. The other thing that you can do, and a lot of times when Clojure developers say they're doing something at the REPL, they have a REPL process running and attached to a file, like this editor file that I have. And they will actually execute these symbols, these forms, in the file. And so here I've executed this def form, and it returns, here's the return symbol in this blue box, and you see that that disappeared. So if I want to, what I can do, I can put my cursor here, and I can say comma, evaluate, and then semicolon, comma, evaluate, semicolon, and it'll print the output to a comment. So I have semicolon, semicolon, and then this equal greater than symbol, and that, or right arrow, and that's just really a symbol prompt. That's what you would see at the REPL oftentimes. And so it's basically saying this is output. So everything after that right hand arrow is my output, and it starts with a reader macro saying, and you remember we saw the var quote, we actually looked that up, so I know that this is actually a var. And in Clojure, we say that this var has been interned in the namespace. And notice that I was able to intern or create this var into this namespace without associating a value with it. If I had wanted to associate a value with it, I could have just put a symbol after it, another form after it, or a primitive after it. So if I wanted the value 7 to be associated with I am a symbol, I could put the number 7 there. And if I evaluated the symbol I am a symbol, I would get back the value 7. One thing, this is maybe the thing with Clojure that is almost this unspoken thing that we don't really talk about a lot, and it is space is, I guess, precious to Clojure programmers and Lisp programmers in general. Like this I am a symbol is a really long name. A lot of times it would just be, a lot of programmers would choose to just use a single letter there. But I'm trying to make a point here. So def, I'm defining a var using the symbol I am a symbol, and then giving it the value 7. So oftentimes in Clojure, you'll have something like this, the name of the symbol and then space 7. You're associating those two things together. Now this is defined in the documentation for def. So I could come down here and just look up doc def. Okay, so this is an example of that case where I don't have doc. I'm just going to switch over here. Stay on schedule here. So here I see that def is a special form. It has a symbol and then optionally a doc string. So this question mark means I could have 0 or 1 doc strings. If this were a plus, it would mean 1 or more. And if it were an asterisk, it would mean 0 or any number of doc strings. So that's an important reading tip for documentation. If you're a new programmer, this symbolism here falls under the category of regular expressions. Normally when you see a question mark in Clojure, it's in the context of a Boolean, which can be true or false. Getting back to our file here, in our next example, I'm using def to define a var. So, and the value of that var is going to be a vector which contains 3 numbers, 3, 18, and 5. Don't know if you could hear a little frustration in my voice just then, but there are some things with Clojure that you sort of wonder, when should I teach this to a newcomer? Because some of the complexities in Clojure are there to keep us as programmers from really shooting ourselves in the foot. And you might be coming from Common Lisp or some other, or Scheme or something else, and it sounds a little confusing to say we have a symbol. So this is a symbol, and we're using this symbol to intern a var in a namespace, and that var is going to refer to a value. And it sounds confusing because, like, okay, well, why doesn't just this symbol refer to the value? And the answer is, for all intents and purposes, when you're starting out, it does. You know, when you evaluate the symbol, I am a vector, you're going to get back that value. This level of indirection between the symbol, the var, and the value is there for our protection. There are certain things that need to be complicated, that need to be a little complicated up front so that it saves a lot more complexity down the road. And a lot of these decisions, you know, they're made by Rich Hickey. He designed the language. He did it for a good reason. He has his reasons. He can be terse sometimes when he explains his reason, but if you parse his language, there is logic there, and he's doing things in a specific way, and they usually entail, you know, he wrote Clojure because he was tired of writing software the other way, at least according to him. And so he's trying to help us to experience more joy when we're programming. And so these things, which may be a little harder to teach in the beginning, do have a specific purpose, and I just wanted to point that out. So here, one of the things that I can do, now that I have this symbol, I can, okay, it's not wanting to let me evaluate this. I'm going to highlight it, and I'm going to do comma evaluate region. All right. So there you can see that when I evaluate the symbol, I am a vector, it does in fact return value, which is a vector that includes the numbers 3, 18, and 5. So this is our pattern. We define something, we give it a name, and that name is associated with a value. And by the way, that value never changes. So like in Python, you might do something like this, where you might say x equals 1, and then somewhere else in your program you might say x equals 3. Well, according to Rich Hickey, and this is one of the biggest, coolest things you can learn with Clojure, I believe, is that this totally destroys, this has no concept of time whatsoever. What this does is this creates a mutable container where x actually does not point to a value, it points to a container which holds a value. And while that's technically what this symbol var relationship does that I mentioned to you earlier, in Clojure, we don't go back and then give vars new values. We just don't do it. So where this is common in Python, in Clojure, we don't use vars as mutable containers. So while a var technically is a container that holds a value, once we write code that has a symbol that points to a var, that references that contains a value, that's it. It's done. One and done. So if we wanted to manipulate this data, what we would do is we'd operate it on a function and we'd output the new data. But we'd give that new data a new name. And so whenever you're sort of not interested in holding on to a piece of data, you don't have to name it. Things can be anonymous inside of Clojure, and that's a signal that you're sort of saying, I want to use this here and now, and then I'll be done with it. The garbage collector, which is inside of Java, or inside the browser inside of JavaScript or Node, the garbage collector will come along and it will destroy any values that aren't referred to anymore. So when we name things, we're saying this is important and I want to hold on to it. So the name's like a handle, then you're holding on to your value with your names. The challenging thing is to develop material that is both engaging for experienced programmers and brings along newcomers. So forgive me for being out of balance in some particular direction or another with where you're at in your learning curve. I am going to, let's see, okay. I'm going to speed this up just a little bit, but there is so much here in this code. There's a lot going on in this code. I just wanted to kind of show you a whole bunch of stuff at once. You can use all the techniques that I've already shown you about looking up things that don't make sense on Clojure's website. So I'm just going to go for it. I'm just going to jump in and go for it. I'm going to run through this and show you this and wrap this video up. And you can sort of pause the video, go back, replay it at will. And if you haven't done the half-screen video setup yet, that will be really helpful for you for this and future videos. Okay. Here, I'm defining a vector of forms, and I'm giving it the name vector of forms. So here's an open parentheses. The thing after that is a verb. This particular verb happens to be a special form. The special form is called def. The name, the symbol for the symbol is vector of forms. Vector of forms points to once this is evaluated, the symbol will point to a var. That var is a container which holds the value, which is a vector. I know it's a vector because it opens with a square bracket. One thing about vars and values and namespaces, to reiterate, we're inside the namespace reading Clojure. So every name that gets interned, every var that gets interned inside of this namespace is a name, and that name is going to be associated with a value. So all that a namespace is a set of names to values, a mapping of names to values, a table of names to values. That's 3 different ways of saying the same thing. And here you can see I have a vector, and the first thing in the vector is a string, ABC. The second thing is a number, 77. The third thing is a character, A. Nil, true, false. The keyword A, the namespace keyword A, the list X, Y, Z contains the keywords X, Y, Z, a vector with the keywords Q, R, and S, a map with 2 keys A and B and their respective values 1 and 2, and a set with 3 unique items, of course, A, B, and C. And finally, a symbol, I am a symbol. When the interpreter sees this symbol, it's going to resolve it to its value. And I think what I want to do here is I just want this to be unbound, so we see what that looks like. Okay, so I'm evaluating these as I go. You can evaluate your whole buffer at the same time if you like. You can be typing these things in at the REPL individually. So like you could be over here and you could be like, okay, I'm typing in def, you know, I am a symbol. And you'll see what you get back. Okay, boom, there's a var. All right. So I have this vector of forms. Next up, I'm just going to demonstrate some things to you. There's a type function that will return the type of the thing for me. So here I'll say, comma, evaluate. Oh, I did it again. Comma, evaluate to comment. Okay, so this outputs java.lang.long. So the type of 3 is a long. That type is coming from the Java virtual machine on which Clojure runs. This is the map function. And very quickly, I just want to show you the best picture, I think, of the way that the map function works. And I hope that Daniel's okay with me using this picture. I'm not making any money on these tutorials, so I'm claiming fair use here, but I do just want to say this is a great book. I have a copy. It's well marked up. I love thumbing through the paper book, and so highly encourage you, if you're in a position to buy this book. This picture that Daniel and his wife have come up with here for mapping functions, you can see you have this sequence of data, x1, x2, x3, x4, and you have this function f. So when you map this function over this data, you get this result data out, and each item in the sequence is manipulated by the same function. And so you could almost just have one picture of a function here, but I really like the way they have that drawn, and encourage you to read this section here. This core functions in depth is priceless. The whole book is, but in particular, these early sections are gold. Back to our example. So here what I want to do is I want to map the type function over my vector of forms. And you'll see I get back the types. I get back a list of types. So it starts with the parentheses. This is a little bit hard to read. Why don't we do this to a comment? So I'll say comma, evaluate, semicolon. This will spit out that data. And here you can see the data begins with an open parentheses. So when data gets output, it won't have that tick in front of the open parentheses. So in this particular case, when data is spit out to the REPL in that context, then it's being treated as data. And that rule of the very first thing being a function after the opening parentheses does not hold true anymore. So I want to be explicit about that. So this is a little bit hard to read. Why don't we try and make this easier? And this is really all about, this is how Clojure works. We take, the data doesn't look the way that we want it to, so we're going to keep working with it and manipulate it until it does. So here I'm defining a function using the define special form. So the first thing after this parentheses is an action, is a verb, and that action is a special form, and we're going to name this function value type pair. And this vector is a special vector. In a function definition, the thing after the name of the function, if it's not a doc string, which is optional, will be the parameter list. In this case, the parameter list has one thing in it, a single value. So this function only defines is a single arity function, meaning unlike the plus function that could be called with any number of arguments, this function must be called with one and only one argument. That's defined in the function signature. The next form after the parameter vector in a function definition will be the body of the function. And so now that I'm in the body of the function, I know that if I see this vector bracket, square bracket, that this is a data structure. And I mean, technically, the function parameter list up here is a data structure as well. It's just that the first vector in a function definition, we know that those are the function parameters. So in my mind, though, you know, like in other languages, there are different ways of defining function parameters. So that's, to me, like, okay, those are the function parameters. Now I'm really thinking of this vector as this is a data structure. The purpose of it is to hold some data. So the last thing, the last form within a function definition is what will be returned by that function. In Clojure, there is no explicit return statement. So the last form is what will be returned. And it may look a little confusing because, well, aren't there multiple forms? This could be a form and this could be a form, and, you know, but it's the fact that all of those forms are inside of this form. So this vector, if there were other forms after this vector, they would be down here, and they would be in line with, they would be at the same level. And so this is where it gets into the fact that Clojure is indentation-based, just like Python is indentation-based. And so we use indentation way more than we use parentheses to sort of read code in Clojure. The parentheses are there just to keep things, you know, entropy at bay. You know, we don't want things flying apart and getting mixed up with each other. It's just like they're containers. This is separate from that, and it creates an orderliness that we appreciate. But it's really the indentation that we're cueing off of, that our eyes are learning to follow as we read the Clojure code. And we're going to get a lot more into this in future videos. I want to get really highly pedantic. And I know I'm going slow, and I know this is taking more time than you're probably used to in other tutorials, but for somebody out there, I know that this is helping them because this would have helped me back in the day. So here I have the final form in this function definition is a vector. And this vector is an ordered list of values, just like any other vector. The first thing in the list of values is the input to our function. So basically what this is saying is I'm going to return a vector where the first thing in that vector is the thing that was input, the value that was input. And I'm matching that up to here where we input it into the function. Just going to give you back the same thing. The second thing in this data structure is going to be the type of the thing given. And so here we have a parentheses. When Clojure comes across this parentheses, it says, oh, goody goody, I get to do something. It's going to be an action. This action happens to be a function. The function's name is type. And so Clojure looks up, it gets the function, it knows, it looks up the function definition, it knows how to call the type function, and it's going to feed a single argument to the type function, which is going to be the value passed in. Again, we're reusing that value that was passed in. It never changes. The value never changes. Values don't change in Clojure. The V is the V is the V. The V is the value. It doesn't change. It's the same here, and it's the same here. If I had done some data manipulation on V and then I reference V again, it's always going to be the same. And that is delightful when you get into higher level programming with Clojure. So let's take a look at what a single invocation of value type pair would look like. So we're going to come down here. We're going to say value type pair. And now I'm going to call the function. So this is the invocation site or the call site of the function, whereas just above it is the definition site. So let's do the value 77. That's the second value in our example above. And I'm going to evaluate that function, and you'll see that it returns a vector where the first thing in the vector is the value itself, and the second thing is the type. So it is what it is. And Clojure is really good at operating on sequences of things. So how can we create a sequence of that little data type that we just saw? You know what I'll do? I'll output that for us. To a comment so we can look at it. And here I'm going to define value type pairs and associate that with the value that is returned by calling the function map. I'm going to map the function value type pair over the vector of forms. This is getting a little more advanced. Not to worry. I'm going to evaluate that. And notice that when I evaluate the def, what I have done is I have interned a var named value type pairs, and I have put the value that is returned by this function invocation. This is a function invocation because it has an open parentheses, and the first thing after it is a function. That's going to go off. This expression is going to be evaluated, turned into a value, and that value is going to be associated with the var value type pairs. So let's come down here and let's evaluate this symbol value type pairs. So the symbol points to a var. The var holds the value. So when we evaluate the symbol, we should get back the value. That's what really matters. I'm going to say, in this particular case, I need to highlight my region again and then do comma evaluate region. Whoops, comma evaluate region. Okay, so I'm getting back a list of collections, each collection being the shape that we've seen before. It has the same structure. And so that's still a little bit hard to read. So what I'm going to do, and by the way, just so you can see, let's see what is the type of the first one of these items in this collection value type pairs. And we see that it is of type Clojure.lang.persistent vector. So this is a symbol, right? This Clojure.lang.persistent vector. Symbols can include dots. So they can include any number of dots, but only a single slash, and that's when you'll know you're dealing with a namespace. So this is where we're going to map the printline function over value type pairs. And this will teach us a valuable lesson by executing this function. So let's do it. Let's evaluate this function. And wow, I get back a list of null values. Nil, 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 nil. Nil is nothing. Nil is not a value. Nil is nothing. The primitive nil just sort of points at nothing. That's all it means. Don't overthink it. And that's because the println function is really about producing side effects. It outputs data to the REPL, and it doesn't return a value. It returns nil. So down below in my REPL, you can see that we have, in the same order as we have up here in this vector of forms, we have the first thing listed is the value, and then we have its type associated with it. So here we have ABC, and it is paired up with its type. It's a string. 77 is a long, A is a character, nil is nil, true is a boolean, false is a boolean, :A is a keyword, :reading dash Clojure / A is also a keyword. It just happens to be a fully namespace keyword. This is a list, a persistent vector. See, we call them persistent because they never change. They persist. These values never change. And we have a persistent hash set. And our final thing here, this was I am a symbol, and you'll notice, so you'll notice it gives it a big long name. It has this reader syntax saying that it's an object, and then we get into this notation with the vector, Clojure.lang.var, unbound, we have a memory address, then we say unbound again, : and finally, then we have a var quote reading Clojure, I am a symbol, and then we close that vector out. So like all of this is actually the thing itself. It's actually the value. This is how Clojure represents that as a value. And then the type is clojure.lang.var, and then it's telling us it's unbound. I know some of this is a little ugly, and I'm not even going to apologize for it. It is what it is. We get some things from the JVM, and you just get used to reading it, and it is helpful when you are debugging for things to be explicit. And so all I can say is, yeah, that's not that pretty to look at, but it does have meaning and it can be helpful. And the JVM is a marvel of engineering. So we're sort of glad that it has the enterprise acceptance that it does, and that Clojure chose to sort of use the benefits, not reinvent the wheel when it comes to garbage collection and all that stuff. So this has been a long-winded exercise in an introduction into reading Clojure, a pedantic exercise. And you hopefully didn't get through all of this in one sitting and took some breaks. But I hope to do more of these, and I hope to bring in more expert programmers than I to help us to understand how they read Clojure code and what their tips and tricks are. Some of the things that I want to get into next time are going to be, there's a couple different ways of reading functions that has to do with how your eye movements go. For example, there's sort of this method, like up here, for example, with this def value pairs. When I'm reading this as Clojure, my eyes just sort of almost skip over all that stuff and go right to this inner function call. It's like I can see there's an inner function call. That's going to get evaluated and turn into a value, and then get associated with this name. So sometimes we sort of go to like an inside out perspective, where let's just say there was another function call inside of this over here. This would actually get called first and resolve to a value, and then this would execute, and then it would get associated with this. So there's sort of this inside-out, right-left method of reading code. Clojure also has a thread, some threading macros, where you will take a form, you'll take a value, and then you'll do something like this, where you will you'll take a value and then you'll operate on it with functions in sort of this railway pattern or track pattern. And that is easier to read in one sense, but it also requires knowing what this symbol means and knowing that you're going to be switching your mode of reading up a little bit. So there are some tips and tricks there that we can learn that will help us read Clojure more effectively, and there may be larger perspective approaches. How do we, if we're coming across a new open source library and we want to dig into the code base, how do we get in there and figure out what it's doing as efficiently as possible? What are the eye movements that we're using? What are the cues in the structure and the syntax of the code that are communicating the intent and meaning of the code? And so if you're a professional developer out there and you have some tips and tricks on reading Clojure you'd like to share with us, we're always willing to, and we're eager to really connect with you and to bring your expertise to our burgeoning community. We're out of Columbia, South Carolina right here. We have 36 members in our new user group, which I started just 2 weeks ago, and we'll have our second meeting tomorrow. And we are roughly the same number of people are coming back to this meeting, and so we had a lot of positive feedback, and we're really excited about that. So thanks again for watching this video. I do hope it was helpful. If this was overwhelming for you in any way, I know this was a lot of information, especially if you're a newer programmer. Hang in there. It does get easier. Get out there, read some code, do some things, and stick with it. And I promise that you will have some victories, and you will feel great once you get some level of proficiency under your belt. Thanks again, and have a great day. Bye-bye.